Giant buildings moving down Highway 4 towards the launch site? How close are we to a finished flame trench and an installed flame diverter? What's the latest forecast for a Flight 9 launch date? Did SpaceX open a portal to another dimension over the UK? Did Saturn's rings just disappear? We have a Chinese space mission with a video. My name is Felix, welcome to What About It, let's dive right in. Starbase's Pad B has been the subject of a massive concrete pouring campaign with hundreds of concrete trucks helping to create the gigantic new flame trench's floor. While this concrete needs to cure for weeks, SpaceX is tackling other equally massive tasks. This massive new bunker building was shipped down to the launch site on mobile transporters a few nights ago. Specifically, this is likely a motor control center, which is used for power distribution in industrial settings as a hub to manage and control electric motors. What better place for it than at the launch site? Also, back at the build site, we've seen holes start to be drilled in the flame diverter. Starship Gazer got a great close-up of this work being done. How long do you think it will be before this is shipped to the launch pad? We also saw the Pad B chopsticks get raised to their full height for the first time. Mechazilla 2 is stretching and slowly coming alive. Hello there, big guy. The high bay deconstruction continues as a tall crane has now been seen pulling out roof beams from the top of the structure along with portions of the gantry crane system. Even though it needed either a full refurbishment or outright replacement, it is wild to see how fast SpaceX moves through outdated infrastructure and how fast things become obsolete. A new and vastly different pad at the launch site and a gigabay at the production site. Starbase stays a place of constant change. But in all this chaos, when can we expect Flight 9? What's the latest status? The prototypes most likely to fly during Flight 9 remain Ship 35 and Booster 16. Ship 35 returned to Megabay 2 on March 13th after cryotests on March 11th and 12th, which appeared to go excellently. Now it's inside Megabay 2, awaiting flap and engine installation. Booster 16 is inside Megabay 1. It did its cryoproof test on February 28th with equally good results. The big twist to this is still Booster 14, which flew during Flight Test 7 on January 16th. There's more and more unofficial rumor that SpaceX might try and refly this super heavy booster on Flight 9 instead of Booster 16. It's also in Megabay 1 right next to its big competitor. The timeline still suggests that we might see Flight 9 launch 4 to 6 weeks after Flight 8, which launched on March 6th. This, of course, heavily depends on SpaceX's investigation into what actually caused the failures of Flights 7 and 8. So patience is needed. We're waiting for news from SpaceX and the FAA. SpaceX put on a spectacular show earlier in the week with the NROL-69 mission. This launch carried secretive cargo involving both the Space Force and National Reconnaissance Office, so details were scarce. Not only did the booster stick the return at the landing site in Florida yet again, but the second stage put on a spectacular light show over Europe. These phenomena can cause a lot of confusion among those who don't know much about spaceflight, which obviously excludes wide viewers. This is similar to a sighting over 15 years ago in Norway, when a Russian-launched missile spiraled after launch due to a failure. Back then, it was caused by leaking propellants. And this time, very likely the same thing. The upper stage deorbited quickly after the launch. After just 1.5 orbits, it landed in the Indian Ocean. This deorbit procedure often involves bleeding off remaining fuel before re-entry. And then if you add an upper stage spin to this fuel dumping maneuver, you get these fascinating geometric shapes. No aliens, no spinning portals in the sky, but definitely a stunning sight. A partial solar eclipse is going to sweep across parts of the northern hemisphere tomorrow, March 29, 2025, offering a unique chance to potentially see sunspots on the sun's surface. Sadly, this won't rival the awe-inspiring total solar eclipse we had last year, but it will still be worth seeing. This event, visible from North America, Europe, Northern Asia, Northwest Africa, Greenland, Iceland, and much of the Atlantic and Arctic Oceans, will unfold in the early morning hours, mostly north of the border here in the Americas. The deepest eclipse will hit northern Quebec, Canada, where the moon will block up to 94% of the sun, while places like New Brunswick and Maine will see an 85% eclipse sunrise, with the sun appearing as a crescent with fiery horns on the horizon. In Europe, the Northwest will get the most coverage, with Edinburgh at 40%, London at 30%, and Paris at 23%, while Morocco in Africa will still reach 18%. This won't just be a visual treat. The Sun's current 11-year cycle, solar cycle 25, peaked in 2024, meaning sunspots, those dark, cooler patches tied to magnetic field activity, will likely be prominent. Using proper eye protection like eclipse glasses or solar filters on telescopes, observers can spot these sunspots as the moon's edge moves across the solar disk. Are you going to try to see this? Let us know in the comments below. If you like our reporting, you can help us out in covering even more. Help improve the channel and double check that you've hit the like and the subscribe button to stay up to date with our updates. It's free and it helps us bring you even better content. Recently, the Florida-based startup Starcatcher Industries marked a significant breakthrough in space-based solar power technology by successfully beaming concentrated solar energy across the length of an NFL football field. They did this at the Everbank Stadium in Jacksonville in the USA, the home field of the Jaguars. Is this considered illegal doping? I mean, charging up like that right before a game? The company transmitted power over 90 meters to multiple off-the-shelf satellite solar arrays, demonstrating that their system can collect, concentrate, and wirelessly deliver energy with the precision required for space applications. The test setup consisted of using existing solar array components commonly found on satellites. This means no retrofitting is needed for current spacecraft to tap into this power source. While Starcatcher didn't disclose the exact wattage beamed, the successful transmission validated the core concept of their technology. It aims to collect solar energy in space and beam it as concentrated light to client satellites. Yeah, crazy. This is a key piece of their planned Starcatcher network, a constellation of 200 satellites in low Earth orbit at around 1,500 kilometers in altitude, designed to deliver on-demand energy to both spacecraft and ground receivers. The company has already raised $12.25 million in a 2024 seed funding round, giving them the resources to push forward and maybe even turn this into a reality. Starcatcher's next milestone is a larger demonstration scheduled for this summer at NASA's Kennedy Space Center, where they'll beam hundreds of watts over a mile across the former Space Shuttle runway, powering mock satellites. This will test the system's scalability and efficiency at greater distances, a crucial step before orbital deployment. Starcatcher's approach of beaming power directly to satellites could enable more ambitious missions like real-time data processing or high-power communications without the constraints of onboard solar panels or batteries. Their focus on space-to-space beaming sidesteps some regulatory challenges of transmitting energy to Earth, though hurdles like launch costs, orbital debris management, and scaling the technology remain. Starcatcher aims to launch its network by late 2025, potentially revolutionizing how we power space infrastructure. Orbital fast chargers. Space-based solar power has long been a topic I'm very interested in, especially beaming the energy down to us. Fingers crossed. Recently, a group of 28 former NASA astronauts threw their weight behind Jared Isaacman, signing a letter to the Senate Commerce Committee to push for his confirmation as NASA's next administrator. These include astronaut legends like Garrett Reisman, who flew on 3 shuttle missions, and Rusty Schweickart, an Apollo 9 veteran who tested the lunar module in orbit. I once had the chance to interview Mr. Schweickart, a true legend and very respectable space traveler. They all joined the call, describing Isaacman as uniquely qualified to lead the agency. In this hyper-partisan age, it is nice to have some unification. Isaacman seems to have widespread approval as the next NASA administrator. And his record is long. He made history, commanding SpaceX's Inspiration 4 mission in 2021, the first all-civilian orbital flight, and Polaris Dawn in 2024, where he performed the first private spacewalk in spaceflight history. He was nominated by President Trump in December 2024, with the formal submission landing on January 20th, 2025. But the Senate has yet to act on this and officially confirm him. Former NASA Administrator Jim Bridenstine echoed this recently, calling Isaacman potentially the most consequential NASA administrator of our time. The Senate Commerce Committee, chaired by Senator Ted Cruz, noted in February that they were still waiting on paperwork, and as of late March, no hearing has been scheduled. Isaacman could inject new energy into NASA. He's a proven innovator, but his job certainly won't be easy. With the Artemis program struggling and the ISS retiring around 2030, he would enter office at a turning point. He's also advocated for a stronger commercial space focus. If confirmed, Isaacman might shift NASA's trajectory, possibly accelerating Moon and Mars ambitions while navigating budget battles and the transition to private space stations. Isaacman's confirmation could set the tone for the next decade of US space exploration, but the Senate's next move will decide when or if that happens. So what's your next move? Will you confirm your place in the Y community? If you appreciate the content, become a channel member or a patron for extra content. Secure your access to up to 7 picture galleries per week, satellite, aerial and ground photos and 3D animations, chat with us and gain more insights on the topics you love. Thank you so much for your support. Saturn's famous rings performed a disappearing act last weekend and stirred up plenty of excitement. They didn't vanish forever, they just slipped out of sight due to a neat trick of perspective. What drove this? What caused Saturn to appear ringless in the sky? A breakup? Did Jupiter get cold feet? Here's the real reason. This happens every 13 to 15 years when Earth crosses the plane of Saturn's rings. We lined up just right on Sunday at 12:04 p.m. Eastern US time, and the rings tilted edge on from our view. Did you know that Saturn's mighty rings are only about 10 meters thick but stretch 274,000 kilometers across? That is just a meter more than the thickness of a starship stretched out to almost the orbit of the moon. When they hit that angle, they caught almost no sunlight and basically disappeared. That tilt shifts how we see the rings over time. Sometimes they are spread wide, glowing bright. Other times, like this past weekend, they become a thin line we couldn't pick out. Way back in 1610, Galileo spotted Saturn with his early telescope and thought the rings looked like weird bulges or ears. It wasn't until 1655 that Christian Huygens figured out they are a disk. They are made of water ice, rock chunks and dust, possibly remnants of a moon or comet Saturn grabbed ages ago. A solid telescope might have shown a faint streak across Saturn's pale yellow globe, but for most backyard setups it was tricky. Still, the planet itself was visible for those up early enough, offering a glimpse while the rings faded away. The rings will dip out briefly again in November 2025, but by 2032 they'll reach maximum tilt, putting on a full display. If you want the best shot at Saturn this year, mark September 21st. That's what's known as opposition, when Earth sits between Saturn and the Sun, making it the brightest and biggest it'll look all year with the rings fully lit up. Here's something crazy to think about. While the weekend's fade was just an alignment quirk, the rings won't last forever. Nothing ever does. Voyager 1 and 2 detected this first, and NASA's Cassini mission, which journeyed through these very rings in 2017, made the readings more precise. The rings are losing ice to Saturn's atmosphere as ring rain at a rate of an Olympic-sized swimming pool worth of water in half an hour. Estimates say they could be gone in under 100 million years, and that's a blink of an eye in cosmic terms. That's half a pool since you started watching this episode. Do you want to be a bit closer to the next celestial phenomenon? Check out redlineheli.com/Felix for a once-in-a-lifetime experience and $25 off flying in a helicopter above Starbase. The Redline helicopter team is waiting for you. They show you the same views our photographers get on their Starbase flights. Just over a week ago, Maya Space, a small launch vehicle developer, spun out of Ariane Group and secured its first commercial launch contract, making a significant milestone for the European space industry. Finally! The French startup signed a deal with ExoTrail, a space logistics company also based in France, to launch multiple space van orbital transfer vehicles starting as early as 2027. While the exact number of launches and financial terms weren't disclosed, we're just happy to hear that there will be vans in space. Just not minivans. Maya Space's vehicle, still under development, is set to begin launches by late 2026 from a repurposed Soyuz launch pad in French Guiana. The rocket can carry up to 1,500 kilograms to orbit in expendable mode, or 500 kilograms when its first stage lands on a barge for reuse, with a kick stage in the works to boost payload capacity further. ExoTrail's space van vehicles, which deploy satellites after reaching orbit, have already flown once on a SpaceX transporter mission in November 2023. The company has 3 more missions planned by 2027, including a geostationary orbit flight on Ariane 6 later in 2026. It's worth noting that the company secured a commercial deal less than 3 years after its founding in 2022. They are moving quickly and others are noticing. So what's next? Maya Space is already working with Arcadia Space, which signed a contract in February 2025 to supply monopropellant thrusters for the launcher's reaction control system while using eco-friendly hydrogen peroxide propellant. While more launches on the horizon, this deal could pave the way for more contracts, strengthening Europe's private foothold in the second global space race. Recently, Pangea Aerospace, a Barcelona-based startup focused on advanced space propulsion, announced a major milestone by securing a €23 million Series A funding round. This investment, led by Hyperion Fund, which raised €150 million as Europe's first fund specializing in aerospace, cybersecurity, AI and defense, aims to bolster Pangea's growth. Pangea plans to use the funds to scale up its manufacturing, integration and testing capabilities, pushing forward its development of eco-friendly propulsion tech. The company is working on a reusable rocket engine using methane and liquid oxygen, designed for a small launch vehicle with a focus on sustainability and cost efficiency. Their tech includes 3D printed aerospike engines, which promise better performance across altitudes compared to traditional bell-shaped nozzles. They've already tested a 20 kN methane engine in 2023. Why does this matter? Pangea's push for reusable green propulsion could help further position Europe as a strong player in the small satellite launch market, where companies like SpaceX or Rocket Lab dominate with reusable tech. Methane engines are gaining traction for their efficiency and lower environmental impact, and Pangea's focus on aerospike technology could offer a competitive edge. So what's the plan? Pangea aims to accelerate its engine development and testing with plans to support launch providers by 2026. Yay for aerospikes! I like aerospikes! NASA recently achieved a major milestone for the Artemis 2 mission, completing the integration of the Space Launch System core stage at Kennedy Space Center in Florida. Technicians with NASA's Exploration Ground Systems program, alongside primary contractor Amentum, used one of the 5 massive overhead cranes inside the vehicle assembly building to lift the 65-meter-tall core stage from the transfer aisle into High Bay 3. There, they secured it between the already stacked solid rocket boosters atop the mobile launcher, marking a critical step toward the first crewed lunar mission since Apollo 17 in 1972. This core stage, the largest component of the SLS rocket, acts as the backbone, supporting the launch vehicle stage adapter, the interim cryogenic propulsion stage, the Orion stage adapter, and the Orion spacecraft itself. Take that out and you got no rocket. The integration followed months of preparation, with the core stage arriving at Kennedy in July 2024 after a 1,450-kilometer journey from NASA's Michoud assembly facility in New Orleans. Since then, teams have been working to ensure all systems are ready for the April 2026 launch, which will send 4 astronauts, Victor Glover, Christina Koch, Reed Wiseman, and Jeremy Hansen, on a 10-day trip around the moon to test the SLS and Orion systems in deep space. So why does this matter? Artemis 2 is NASA's first crewed mission under the Artemis program, building on the uncrewed Artemis 1 launch in 2022. The core stage's integration brings the mission much closer to reality, moving NASA further down the path toward ignition. However, the program isn't without scrutiny. The Space Launch System has faced criticism for its high cost, estimated at $2 billion per launch, and delays. Artemis 2 was originally slated for 2023, but pushed back due to issues like Orion's heat shield damage after Artemis 1. So what's next? Teams will now integrate the upper stage, which arrived on March 9th, and the Orion spacecraft, which is expected in the vehicle assembly building by late April or early May. NASA is working to accelerate the timeline and aims to buy back months from the April 2026 target. That would build confidence. This mission will set the stage for Artemis 3, planned for a lunar landing no earlier than 2027. So, what do you think about the Artemis program so far? I'm working on an in-depth video covering the topic, and I would love to hear your thoughts. Earlier this month, the Shenzhou 19 crew aboard China's Tiangong space station completed its 3rd spacewalk. 7 hours floating in space. Astronauts Kai Shuzhe and Song Ling-dong exited through the Wenqian Science Module's airlock, focusing on installing the final set of space debris protective shielding on the station, a task that required multiple EVAs to fully implement. And we got video. They also installed extravehicular auxiliary facilities and conducted inspections of Tiangong's external equipment and systems. Inside, crewmate Wang Haoze provided support coordinating with ground teams at the Pangea Aerospace Control Center. This spacewalk marked China's 20th EVA overall and a personal record for Kai, who became the first Chinese astronaut to complete 5 spacewalks, having performed 2 during his Shenzhou 14 mission in 2022. The Shenzhou 19 mission, which launched last October from the Jiuquan Satellite Launch Center aboard a Long March 2F rocket, has been packed with activity. The crew's first spacewalk on December 17th lasted over 9 hours, setting a new record for the longest EVA by Chinese astronauts. Their second on January 20th lasted more than 8 hours. Man! Tiangong completed in 2022 after the assembly of its 3 modules, Tianhe, Wenqian, and Mengtian, is a cornerstone of China's space program designed to operate for at least a decade. The station weighs about 20% as much as the mass of the ISS and hosts rotating crews for 6-month missions, with Shenzhou 19 being the 8th crewed flight since 2021. That place is buzzing. What's next? The Shenzhou 19 crew is nearing the end of their 6-month stay, set to hand over to the Shenzhou 20 team around late April 2025, with Shenzhou 21 to follow later in the year. The Long March 2F rocket for Shenzhou 21 is already at Jiuquan, prepared for a rapid response launch if needed. China is progressing fast. What do you think about their progress with Tiangong and their spacewalk milestones? That's it for today. Remember to smash that like button, subscribe for more. This is what fuels the algorithm, and this is how you can help us for free. Check out our epic shirts in your favorite Space Nerd store. A new Raptor design and our brand new Starship Block 2 design are both up. Link is in the description and in the card you should see now. Also check out our print store at shop.whataboutit.space to buy a picture for your favorite wall. A significant amount of every purchase goes directly to our photographers. And if you've always been wondering why starships don't have any legs, watch this video next to continue your journey. Thank you very much for watching, and I'll see you again in the next episode. Pangea plans to use... I'm sorry. Possibly remnant... Yeah, good blooper. Nice.